Okay, let's look at that. So this implies, we separate the variables here. Uh, we have, just the first thing, multiply both sides by dx. So this is x dy is equal to 4y dx. And then the next thing that we want to do is to divide both sides by x, divide both sides by y. So in doing that, we have 1 over y dy is equal to 4 over x dx. Now we integrate both sides. There's the integral of 1 over y dy is equal to 4, or if you're from South Alabama, 4 times the integral of 1 over x dx. So the left side gives us the natural log of the absolute value of y. That's equal to 4 times the natural log of the absolute value of x, plus some constant that I would just say call c sub 1, just to confuse the heck out of you even more. So no. Well, we're gonna have another constant to come in there. So now I'm gonna get the so-called natural logs together. So this is the natural log of y minus the natural log of the absolute value of x to the 4th is equal to c sub 1. Right? That 4 became, that's a multiplier. The 4 becomes an exponent. Right? So this is the natural log of the absolute value of y all over x to the 4th is equal to c sub 1. Exponentiate both sides. So we'll come over here. So in doing that, we have y over x to the 4th is equal to e to the c sub 1. I'm just going to let e, which is a constant, raised to a constant, I'm just going to let that equal to c. And so we have y is equal to c times x to the 4th. And in the words of Doc Holliday, isn't that a daisy? Well, it's probably a dandelion for right now. We'll get to some daisies later on with the more these problems get complicated. So that was number 5. Let me move on. Let's see. Number 17. Number 17. So what I'm going to do here is multiply both sides by dt. So this is dp is equal to p minus p squared, parentheses, times dt. Divide both sides by p minus p squared. And if you will, I'm just going to go ahead and just write that in terms of how I want it. This is p times parentheses 1 minus p times dp is equal to dt. Is everybody with me so far? All right. Integrate. We do not hesitate, we integrate. It's just a math joke, but nobody laughs, right? Nobody laughs at my jokes anymore. So, how do we integrate the left side? It'll still get you the same thing. All right. You'll end up right where you started if you do that substitution, right? Any ideas? remember now that everything that you learned basically in Calculus 2, I think that was the class where you had several integration techniques, right? So it could range from integration by parts, partial fractions, UDU substitution, trig substitution, and the list just goes on and on. Yes, sir, Wes. Pardon me? No, you can't do that. That's illegal. Yep. Don't tell nobody that. Anybody say integration by parts? So here we have 1 over p times 1 minus p. The only time you can break terms up, like what you were saying, Wes, if the emphasis of the decomposition is in the numerator. It has to be a, don't write this down. If it's a minus b over c, you can break that up as a over c minus b over c. But if it's a over b minus c, that is a over b minus c. Right? You don't break that up. Now you can break it up, but you have to divide b minus c into a. You can do that. But if the numerator is less of a power than the denominator, then there's no sense of dividing, because it's already improper. So we write this as a over p plus b over 1 minus p. It's not an L, it's a 1. Multiply both sides by p times 1 minus p, and so we end up here. Let's say this implies that 1 is equal to a times 1 minus p plus b times p. Let p equal to 1, and that implies that this one here is equal to, if p is 1, this is 0, and this is 1 times b, so 1 is equal to b. And then secondly, if we let p equal to 0, so we have 1 is equal to a. So if that be the case, then this integral of 1 over p times 1 minus p is a over p, or 1 over p, plus 1 over 1 minus p dp. That's equal to that integral of dt, which is just little t, when we're finished with that. So the integration of the sum is the same as the sum of the integration. So this is the integral of 1 over p dp plus the integral of 1 over 1 minus p dp. The integral of dt is just little t, and here plus some constant we'll call c sub 1. Integrate 1 over p, and what do you get? Natural log of absolute value of p. You integrate 1 over 1 minus p dp, what do you get? Bless you. Oh! That's my high school math teacher. That's Mr. Harold, man. He scared the mess out of me. Oh, what's wrong with this guy? Somebody call 911, you know. What's the integral of 1 over 1 minus p dp? Is the answer up there? Folks just looking around like. Scaring me. I don't know what that was. So, yeah, but that just complicates it. Why make it hard, guys? We're trying to make life easy. No, it's negative times the natural log of 1 minus p. I didn't hear the negative. Why is there a negative? Because 1 minus p, let that equal to u. And du is negative times dp. So you have a negative, right? Again, that's the u du within integration, what is this, partial fractions. Right? See that 1 minus p? You got to be careful. See here, if you have p there, let u equal to p, and so du is dp. Well, you already get that automatically, right? But over here, if you let u equal to 1 minus p, then du is negative dp. Right? So this negative here is important. Now that's right there from calculus too. So we're not talking about something that you don't know. You're supposed to know. Right? All right? Make sure you go back and learn that. So this is the natural log of p all over 1 minus p. This pen does not write so well, I think. 1 minus p is equal to t plus c sub 1. So exponentiate both sides, and we have p all over 1 minus p is equal to e to the t plus c sub 1. And this is p all over 1 minus p is equal to e to the t times e to the, no, too much. Times e to the c sub 1. Let capital C equal e to the c sub 1. So p over 1 minus p is equal to c times e to the t. Now look in the back of the book, and this is what number? Number 17. And tell me if this answer is not the same answer that they have in the back of the book. And if it's not, you make it be so by using some algebra. Let me see. Who was that? Was that Doc Holliday said in Tombstone to Ike Clanton? I think they were playing poker or something, and Ike was losing, and so Doc said, "I know. Why not let's have a spelling contest?" So that answer that I just gave you here, if that's not the same answer they got in the back of the book, let's have an algebra contest and see if we can make this answer be the answer in the back of the book. Did anybody check it? Okay, it does. She said it doesn't match. Is this answer wrong? Okay. Can you make this answer be that answer in the back of the book? Well, one answer is yes. We just say yes, it's the same thing and move on, right? Oh, we can do algebra, right? We remember what algebra is. Well, we still use algebra, guys. This is still a math class, right? Right? Can you make that? Because the answer in the back of the book is P equal to What is that? E. Does anybody have it in the back of the book? C e to the t over. Oh boy. So how does he get from the left to the right? Bless you. Do you say that these two answers are the same? And if so, then, mathematically, show me. But one thing's for certain, y'all vision is really good, boy, because we can really look at something, right? We're just you got good vision. Now, let me see if you can use your hand. And as my professor would say, I'd go to him and ask him about a calculus question. He'd say, you got to use your hand. Okay, you're scaring me. So look, this is P over 1 minus P is equal to C to the ET. That's what I had. I'm going to multiply both sides by 1 minus P. We'll say this implies that P is equal to 1 minus P times that C times e to the t. You can break that up. So this is C times e to the t minus P times C times e to the t. Right? So I have here, this is P plus P times C times e to the t is equal to C times e to the t. Factor out of P, I have 1 plus C times e to the t is equal to C times e to the t. Divide both sides by that 1 plus C times e to the t, and you get it. So the answers are the same. Okay. Now I have dealt with 2 points here as I try to conclude this idea. One is that your answer may be the same answer that's in the back of the book. Don't be alarmed if what you have looks different than what they have. They just might be the same. Algebra can help us connect the two, right? The second point that I want to conclude with here is that if on the test you write your answer one way, I'm not looking for a certain way of how the answer is supposed to look. So if you write your answer the way I have this answer right here, when we concluded that, if your answer is written like this, I'm fine with that. Okay. Well, what if a person writes their answer like this over here? Well, I'm fine with either one. It doesn't matter with me because I know what the answer is. Okay. So don't think that, I'm trying to teach you how to get the answer in a certain form or a certain format. It's fine with me. They're all going to be equivalent if they're all right. Right. They'll be equivalent. Okay, good. Any questions there? This is number 19. That's number 24. Let me look at 19, but my goal is to do 24, and then I'll be finished with this section. Then I have a problem for you to do. And then we'll go home. Let's look at number 19, I'm sorry. So we're going to multiply both sides by dx, multiply both sides by this denominator here as well. So when you do that, we have x, y, minus 2x plus 4y minus 8. This is all times dy, and that's equal to x, y, plus 3x minus y minus 3 dx. Now, if you look at this right side here, all that stuff can be broken down by just mere simply factoring. So let's look at here. These two terms have an x that's common, so we factor that out. We have y minus 2. The next two terms have a 4 that's common, plus 4 times y minus 2. That's all times dy. That's equal to the same thing on the right side. We could factor out an x. So we have here left y plus 3. And then this is minus 1 there, if you will. Y plus 3 times dx. Okay, this is 4. All right. So now this left side is x plus 4 times y minus 2 dy is equal to the right side is x minus 1 times y plus 3 dx. Now we separate the variables, right? So we divide both sides by x plus 4, divide both sides by y plus 3. So we have y minus 2. This is a good problem. Divided by y plus 3 dy is equal to x minus 1 all over x plus 4 dx. So now we integrate. And just put the integration sign right there, right? Okay, so let's recap. From the problems that we've talked about so far in terms of integration, we have seen du substitution. Right? We've seen partial fractions. So to integrate these two sides, what technique do we use? Does anybody have my calculus 2 class? Okay, so you better say it. No. Well, is it good? Yeah, that's very long, right? How would you integrate that? Okay, everybody, you got to go back to Calculus 2, Chapter 8. I think that was the chapter that had all those integration techniques. Right? And I think that first section, 8.1 and 8.2, had like a review from some of the techniques from Calculus 1, of which this will be one of them. If it's an improper fraction, divide. Do you remember that? Boy, y'all hurting me. Y'all are hurting me. You know, I've thought about just going back farming, you know. I tell you, it's the best life, you know. Because you cultivate that land, you put those seeds down in there, proper water and, you know, cultivation, get those weeds out, and you just allow the Lord to bring his sunshine and rain. That corn comes up, man. Oh, praise the Lord. You know? It's like what you put in with his grace is what comes out. Huh? That is true. That is true. That is true. It's like the story I heard about. You heard about the story about GPC, about the farmer was out there farming. He was working out there in that field. He looked up in the sky. Up in the cloud was 3 letters, GPC. Anybody heard that? He saw GPC. He said, GPC, what does that mean? GPC, go preach Christ. So he got rid of all his farming equipment, started preaching, went across the country preaching the gospel. He was the worst preacher in the world. Nobody really wanted to hear this guy preach. He really couldn't preach. And folk would tell him, you can't preach. Well, that's not good to say to a preacher, I reckon. You can't preach. So, and they lived in poverty. And he thought, hey, this can't be. So years later, he ended up dying and went to heaven. This is just a story. Got up to the gates and spoke to old St. Peter and said, St. Peter, so what happened? I gave my whole life. I saw the letters up there in the sky that said GPC, go preach Christ. He said, I gave up my farm and equipment. I started preaching, and how come nobody listened to me? All this. And so St. Peter said, you idiot, GPC, go plant corn. Right? So my point is, I've been thinking about going back farming. Oh boy, okay, I'm not going to finish my point. But anyway, you remember that this guy, look at y minus 2 divided by y plus 3. It's an improper fraction, right? We said that a fraction is improper. Even going back to arithmetic, a fraction is improper if the numerator, the power of the numerator, is either equal to or greater than the power of the denominator, right? It's said to be improper. Well, the numerator, that power is 1, and the denominator, that power is 1. Improper. If it's improper, we say divide. So here, this is integration by dividing an improper fraction. So we have y plus 3 divided into y minus 2. So y goes into y one time. 1 times y is y. 1 times 3 is plus 3. We draw a line, subtract. So we get negative 5. So that gives us 1 minus 5 over y plus 3. So that's the first one. So now x minus 1 divided by x plus 4 is also improper. So x plus 4 divided into x minus 1. X goes into x. 1 time x is x. 1 times 4 is plus 4. Draw a line, subtract. So we get minus 5 there. So this is 1 minus 5 over x plus 4. So the first integral is 1 minus 5 over y plus 3 dy is equal to the integral of the sum of 1 minus, or difference that is, 5 over x plus 4. So we integrate. So here this becomes y minus 5 times the natural log of the absolute value of y plus 3 is equal to x minus 5 times the natural log of the absolute value of x plus 4 plus c. And you can just leave it just like that. I'm fine with that. I mean, you can take it another step, to try to clean it up. It doesn't matter with me. If you went further, again, I'm fine with that there, right? That's okay. The back of the book, the answer may be different, so let's see if we can try to match up with what he has. Subtract the x on both sides, so you get y minus x. I'm going to add this 5 natural log of y plus 3 to both sides. So this is 5 natural log of y plus 3 minus 5 natural log of x plus 4 plus c. Make the 5's exponents, and then this natural log of the difference becomes the quotient of the natural log. So this is y minus x is equal to the natural log of y plus 3 over x plus 4 raised to the 5th power plus c. Let's call that c sub 1. Exponentiate both sides, so we get e to the y minus x is equal to some constant times y plus 3 over x plus 4. That's all to the 5th power. Right? So you could take it further, or you can leave it like how I had it up here. Either one is fine with me. Okay? Any questions? The last problem deals with initial value problems, where a differential equation is given and they have an initial condition, and then they want you to be able to satisfy that initial condition. Simply, if there's an initial condition given, then they simply want you to really solve for the constant and then put that part back into the answer. So look at number 24. Initial condition is given. That is, when x is equal to 2, y is equal to 2. If anybody came in after I called the roll, make sure at the end of class you come by and let me know so I can put you on the roll. So we're going to separate the variables. Here we cannot have a differential in our denominator in terms of integrating. So we have 1 over y squared minus 1 dy is equal to 1 over x squared minus 1 dx. Does everybody see that? So we need to integrate both sides. This y squared minus 1 is the same thing as y minus 1 times y plus 1 dy equal to the integral of 1 over x minus 1 times x plus 1 dx. What is our technique here of integration? I wouldn't. That would be difficult, I think. I would like to see you do it. Not right now. Anyone else? Partial fractions? So you have 1 over y minus 1 times y plus 1 is equal to a over y minus 1 plus b over y plus 1. And then you do the same thing over to the right side. So this is 1 over x minus 1 times x plus 1 is equal to a over x minus 1 plus b over x plus 1. Notice that the left side is almost the same as the right side. It's just Just instead of x is a y, right? So I'm going to solve the left side, and whatever answers I get for a and b, they'll be the same thing for the right side for a and b. Do you see that? So instead of having to do too much work, so here we multiply both sides by the LCD, so we get 1 is equal to a times y plus 1 plus b times y minus 1. And hopefully, you know, when you were doing the partial fractions, whether it was Math 112 or Calculus 2, you get to a point where you kind of see, you know, the solutions, if it's simple. So here, if we let y equal to 1, that'll cancel out the b, right? So then we'll get 2a is equal to 1, so a is equal to 1/2, right? So a is 1/2. Same thing over here. A is 1/2. If you let y equal to -1, y is -1, that cancels out the a. I get -2 times b is equal to 1, so b is equal to -1/2. Okay? So the left side, we have the integral of, it's the a over y minus 1 plus b over y plus 1. Right? So a is 1/2 all over y minus 1. Then it's a minus 1/2. This is y plus 1 dy. That's equal to the integral of a, which is 1/2 all over x minus 1 minus 1/2 all over x plus 1. This is dx. So we integrate. We have 1/2 times the natural log of the absolute value of y minus 1 minus 1/2 times the natural log of the absolute value of y plus 1 is equal to 1/2 times the natural log absolute value of x minus 1 minus 1/2 times the natural log of the absolute value of x plus 1 plus c. You can make those 1/2s powers, or you can just, since they all have a common term of 1/2 through there, just multiply everything by 2 and just get rid of those 1/2s. It'll be 2 times that c over there, and that's fine. Right? I guess we better call it c sub 1. Multiply everything by 1/2. Get the terms together, so this becomes the natural log of y minus 1 all over y plus 1 is equal to the natural log of the absolute value of x minus 1 all over x plus 1, and that's plus 2 times c sub 1. So we know what we do when we have natural logs. We exponentiate both sides. Right? So we do that. We have, yes, y minus 1 over y plus 1 is equal to x minus 1 over x plus 1. You might not see it. I got to go back and blow it up. I'm sorry. This is e to the natural log of all of that stuff. Is equal to e to the natural log of x minus 1 over x plus 1. And this is plus 2c sub 1 or times e to the 2c sub 1. Okay? Everybody see that, right? So now, let let c equal to e to the c sub 1. So when you do that, we have y minus 1 over y plus 1 is equal to c times x minus 1 all over x plus 1. Now the initial condition was that y of 2 is equal to 2. So y of 2 is equal to 2. So the point is just 2 comma 2. When x is 2, y is 2. So we plug in x to equal to 2. We plug in y to equal to 2. So we get 2 minus 1 over the 2 plus 1 is equal to c times the same thing, 1 over 3, whatever. 2 minus 1 over 2 plus 1. And that just ends up giving us c is equal to 1. Yes. Okay, we go back to the properties of exponents. If it's e to the to the m plus n, that's equal to e to the m times e to the n. Right? So this guy here was e raised to all of this, right? So it's e to the m times e to the n. So this e to the 2c sub 1 is here, so it's times. So I call that just equal to c, because it's a constant raised to a constant. Right? Just going back to just a particular property of exponents, that's all. Yep. I have not created any new math. Right? Not yet. I am working on something. So this implies that, you see that c is equal to 1. Right? So the answer is y minus 1 over y plus 1 is equal to x minus 1 all over x plus 1. So that is tantamount to saying what? Y is equal to x, yeah. Strictly symmetric in all of its setup here, so. Yeah. But again, you could say the first part for your answer or the second one, it doesn't matter. Okay, you do number 25.